It is a marvel of modern engineering. The Boeing 787 Dreamliner, a machine designed to fly, higher, faster, more efficiently, its sleek wings cut through the air. Its revolutionary carbon fiber body promised a new age of air travel. Passengers were told it was the future, airlines believed it was the key to their success, but hidden deep within its advanced structure, a secret was waiting. A quiet, almost imperceptible flaw, a whisper in the fuselage that threatened to become a roar. No one knew it was there. Pilots, passengers, people who built it. A discovery was about to be made that would shake the aviation world to its very core. This story doesn't begin with a bang. It starts with a hum, the quiet, steady hum of a routine maintenance check. In the vast, brightly lit hangars where these magnificent birds rest, technicians perform their careful ballet of inspection and repair. Our timeline begins on a cool spring night, April 12, 2024. The location is a sprawling maintenance facility in Dallas, Texas. An American Airlines 787 sits in a hangar for a scheduled C-check. Close up on registration N820AL. This is a heavy inspection. It happens every couple of years. Panels come off, systems are exposed. Technicians swarm over the aircraft, inspecting every inch. It's routine, done thousands of times a year worldwide. But this night, routine was broken. A senior airframe technician was about to find something extraordinary. His name, David Chen, over 20 years of experience. He'd worked on old McDonnell Douglas jets, and the newest Airbus models. He knew the feel of a solid airframe. He was using a high-frequency ultrasonic scanner. The device sends sound waves into the fuselage to find hidden delamination. It's like giving the plane an ultrasound. He passed the scanner over the rear fuselage near the aft pressure bulkhead. His screen flickered. He saw an echo, a shadow where a solid signal should be. It was faint, but it was there. The initial report from Dallas sent a jolt through Boeing's engineering teams. They immediately requested the aircraft section be analyzed further. A specialized team was dispatched from Seattle. They arrived with more powerful, non-destructive testing equipment. They weren't just looking at the shadow anymore. They were mapping it in 3 dimensions. What they confirmed was deeply troubling. The anomaly was a small area of delamination. In simple terms, the baked-together layers of carbon fiber composite were beginning to separate. It was like a page in a book coming unglued from the spine. This was not supposed to happen, not without some external damage. The investigation quickly zeroed in on a specific area. The problem was appearing near the titanium fasteners. These are the bolts that hold different composite sections of the fuselage together. The Dreamliner's body is built in large, barrel-like sections that are then joined. The bolts are critical. They are the stitches holding the whole thing together. The theory that emerged was shocking. It seemed that tiny, almost immeasurable variations in the torque, the tightness of these titanium bolts were creating stress points. To understand why this was so surprising, you have to understand the promise of the Dreamliner. Boeing sold the 787 on the idea its composite fuselage was more durable than aluminum. It was less susceptible to fatigue. It was less susceptible to corrosion. This meant fewer heavy structural inspections were needed over the life of the plane. That was a major selling point for airlines. Less time in the hangar, more time in the air, making money. The discovery of the composite ghost turned that entire premise on its head. The problem wasn't just that there was a flaw, it was a type of flaw that the maintenance schedule was not designed to find. The issue was traced back to the assembly line. During the 787's early production years from roughly 2009 to 2015, the process for tightening these critical fasteners was less automated. While specifications for torque were precise, the real-world application could have tiny variances, a few foot-pounds of pressure here or there, a microscopic misalignment. Humans, even highly skilled ones, are not robots. These minute inconsistencies, perfectly acceptable in a metal aircraft, were having an unforeseen effect on the composite structure over time. The news did not break to the public immediately. For several weeks in late April and early May 2024, the FAA and Boeing worked behind the scenes. FAA worked behind the scenes. Boeing worked behind the scenes. They needed to understand the scope of the problem before causing a global panic. Information this big is hard to contain. On May 21, 2024, a leaked internal memo found its way to a major news outlet. The story exploded across media. Headline, Hidden Flaw Found in Dreamliner Fleet. Headline, Safety of Boeing 787 Questioned. The public reaction was one of immediate fear and confusion. The 787 was one of the world's most popular long-haul aircraft. Millions of people had tickets to fly on one. Authorities tried to manage the message carefully. The FAA issued a statement. They said they were working closely with the manufacturer to determine the full scope and ensure safety. The statement was meant to be reassuring. For many, it was not. The word flaw associated with an airplane is, honestly, terrifying. The European Union Aviation Safety Agency, or EASA, quickly followed with its own alert and independent review. Aviation regulators worldwide were now on high alert, and they were all looking directly at Boeing. Experts in the aviation community were divided. The consequences for airlines were immediate and immense. In the first week of June 2024, the FAA issued an emergency airworthiness directive. It was a clear and unavoidable order. All Boeing 787 aircraft manufactured before 2016, nearly 500 airplanes worldwide, were to be temporarily removed from service. They needed to undergo immediate ultrasonic inspections of specific fuselage sections. This was not a suggestion. It was a mandate. Suddenly, a significant portion of the global long-haul fleet was grounded. The ripple effect was catastrophic for summer travel plans. Airlines scrambled to cope. They faced an operational nightmare. International schedules were thrown into chaos. United American Japan Airlines were forced to cancel hundreds of flights. They had to substitute other older aircraft where they could. Boeing 777 Airbus A330. But there simply weren't enough spare planes to cover the gap. Passengers were left stranded. Vacations were ruined. Business trips were canceled. For the Boeing company, the discovery of the Composite Ghost was a corporate crisis of the highest order. Stock price tumbled more than 15% in the week after the news became public, facing a firestorm of criticism from airlines, regulators, politicians, the public. Production of new 787s at their South Carolina plant was immediately halted pending a full review of assembly procedures. Fighting a war on three fronts: a technical crisis, a financial crisis, a public relations crisis. The pressure was immense and the stakes could not have been higher. Boeing's CEO addressed the public in a televised press conference. His tone was somber.
"We are deeply sorry for the disruption this has caused to our airline customers and the traveling public. Safety is our North Star. We are taking this matter with the utmost seriousness. We are deploying our top engineers to work 24/7 with the FAA and our customers to resolve this.
We will be transparent, we will be accountable, and we will make this right." The words were correct, but the public had heard similar promises before. Now they were waiting for action, not just words. The technical fix was complex and costly. The aftermath of the Composite Ghost discovery brought about significant and lasting changes to the aviation industry. The most immediate change was in maintenance procedures. The advanced ultrasonic inspection performed by David Chen in Dallas was no longer just for heavy checks. It became a required recurring inspection for all 787s and for many other composite aircraft. Regulators mandated a new schedule of checks targeting areas around fasteners on composite structures. The industry had learned a hard lesson. New materials require new ways of looking for trouble. Maintenance manuals across the world were rewritten. Boeing, under intense pressure, implemented sweeping reforms on its assembly lines. They invested heavily in new automated systems for drilling and for fastener installation. Robotic systems could apply torque with precision and consistency beyond human ability. Every fastener's torque value was recorded, stored in a digital record, and tied to the aircraft's serial number. This became a digital birth certificate for the plane's structure, allowing perfect traceability. The era of slight variations in assembly was over. The new standard was absolute, verifiable precision. The role of the FAA and other global regulators evolved. Looking back from today, September 10, 2025, the Composite Ghost incident stands as a pivotal moment in modern aviation history. It did not lead to a crash, no lives were lost, and in that, we can find a measure of success. A technician did his job, a safety system worked, a potential catastrophe was averted. But the lessons learned from that quiet discovery in a Texas hangar are profound and must not be forgotten. It reminds us that with great innovation comes great responsibility. The rush to create the next best thing can never be allowed to outpace the diligence required to ensure it is safe. The story of the 787's hidden flaw is a testament to the importance of the human element in an increasingly automated world. It wasn't a computer algorithm that found the problem, It was an experienced technician who saw something that didn't look right and had the courage to speak up. The pursuit of safety is a journey, not a destination, and it is a journey that requires constant vigilance, a willingness to learn from our mistakes, and the courage to look for the ghosts we cannot see.